Good morning, students. Welcome you all to this online lecture series on website design. As you know, in the previous lecture, we studied in detail the computer-aided design tools which are used in digital systems, hardware description language, and introduction to VHDL. So in today's lecture, we are going to do the revision of other few topics of this unit, that is basic details of VHDL. So as you see on the slide, so today we shall study details of data objects, classes and data types, and various VHDL operators. As you see on the slide, so the first topic of today's lecture is data objects. So what are data objects? The definition says that the data objects are those components of VHDL code which are used to hold a value of a specified type. So it is basically created by means of an object declaration. Let's see one example. As you see, a count data type or data object is created which is variable and returns the integer value in the code. Now what are the types of data objects? As you see, there are 4 types of data objects. These are signal, variable, constant and file. So let's discuss these 4 in detail now. So the first component is signal. So what is signal? The signal is used to hold a list of values of a given type. So it takes into account the present and all set of future values which can be possible. So it can assign new values to the object. Now another important feature of signal is that it have attributes. What that means it allows user to extract additional information from an object which is inside the code. So let's discuss one example. As you see, the data flow data object is created for the logical operation drive under the block architecture. The signal declaration is done as per the syntax. As you see in the slide, the signal with signal name and signal type. So here the signal declaration is done as per the signal syntax, which is signal name X with the type such that X is less than equal to A or B. So here the signal assignment symbol is X is equal to Y, which says that Y is equal to Z or A and Z is equal to B. So in this way the signal assignment is occurred at the end of the process which stores a real data. So the changing in signal value is created under this type of signal in the data object. So let's move to the next slide for the study of variable. The definition says that a variable holds a single value of a given type. Also, it is used to store local temporary data where new values of same types are assigned to the object. So as you see in the example, the variable assignment is easy to write and it can be complex to synthesize otherwise. So such problems can be of high level algorithm calculations. As you see in the example, the 8 input AND gate logic is written, which is using the variable temp of the type bit in the code. So the temp variable is used inside whose values are changing as per the for loop, which is applied for 7 down to 0 values of I. Now let's study in detail new data object that is constant. Now the constant is used to hold the single value of a given type. The constant name specifies values to make the model better documented and easy to update. The constant is declared initially in the VHDL statement. This is basically used for constant value of a signal or a variable. And it must be kept in mind that values of constant cannot be changed inside the code. So as you see in the slide, the constant declaration is done as per the syntax, which is constant with constant name and constant type, which is value. So here constant name is RST level with constant type bit and returning the value 1. So in this way the constant is declared inside the VHDL code. So now the last part is file, which is basically used to access file on disk. So in order to use the file type, user must include the input output package that contains all the procedures and functions. So that allows users to read from and write to in the coding files. So in this way the file is used. I hope you have now understanding of this topic of data objects. Now let's move to the next slide for the study of classes and data types. So what is the meaning of class or data object class? It is basically that part to which every data object belongs. So what is the meaning of this statement? It means that every data object belongs to one of the data class. So in this VHDL language, there are basically 3 classes: constant, variable, signal. Let's discuss briefly these 3. An object of constant class can hold a single value of a given type. Now it must be noted that this value is assigned to the object before the start of the simulation. And also the value cannot be changed during the course of the simulation. In the variable class, an object can hold a single value of a given type. But in this case, different values can be assigned to the objects. So this value assigning is done at different times using a variable assignment statement. Now signal class is the class to which objects belongs, which has past history of values, current values, and possible set of future values. As you know, these all values are assigned using signal assignment statement in the VHDL code. Now let's study the various data types. The data types are further of 4 types, that is file, access, scalar, and composite. The scalar type is further categorized into 4, that is physical, integer, real, and enumerated. The composite is of 2 types, that is arrays and record. So let's study these in more detail now. As you see on the slide, the scalar has 4 types, that is enumerated, integer, real, and physical. So the enumerated type is that in which the list of distinct values are there for an object. It means it is predefined type like boolean, bit, and character. Similarly, integer type is that which has set of whole numbers, that is positive and negative, and it is defined as predefined type integer. So the range is 32-bit signed values. It is often used for the reduced range of synthesis. So example is given here that integer range is -64 to +64. And similarly, the float type is that type in which the float point numbers are defined, and it is also called as a real type, and it is of 32-bit single precision, and it is not for synthesis. It is used where hardware is too complex. And the last is physical type, which measures the different measurements such as time, which can be measured in femtosecond, picosecond, nanosecond, minute or hour. So these units are not used for synthesis, and their conversions are done in terms of bits. So there are two types of composite data type, that is array and record. An array type is that which represents a collection of all those values that belong to a single type. And on the other hand, a record type represents a collection of values that may belong to same or different types. So the access data types are those which allows to manipulate data, so that data may be created dynamically during simulation. And the file data type is that which is used to define the objects which are representing files in the host environment. So here it must be noted that the value of the file and file object is the sequence of values contained in the physical file. So I hope you have now thorough understanding of this topic of class and data objects. Now let's move to the next slide for the study of operators. So what is the meaning of operator in the VHDL? The definition says that operators are those which are used to perform specific operation inside the VHDL code. So there are many predefined operators in the VHDL language. These are logical operators, relational operators, adding operators, multiplying operators, miscellaneous operators. So let's briefly discuss these. The logical operators are basically of 6 types, that is logical AND, OR, NAND, NOR, XOR and NOT. And similarly, the relational operators are of 6 types: is equal to or not equal to, less than, greater than, less than equal to or greater than equal to. And similarly, adding operators are there, that is for addition, subtraction and concatenation. Similarly, multiplying operators are there. These are multiplication, division, modulus and remainder. And similarly, miscellaneous operators are there, which are absolute and exponential. I hope you have now thorough understanding of this topic of operators. So this was all about today's lecture, where we revised various basic details of VHDL. As you see on the next slide, in the next lecture we shall study another important topic of this unit, that is overloading, logical operators, types of delays, entirety and architecture declaration. So we shall discuss these topics with suitable examples in the next lecture. Thank you.